Today we're going to talk about the discriminant, and let's begin by looking at the quadratic formula. Suppose we have a generic quadratic equation, ax squared plus bx plus c equals 0. In this equation, a, b, and c represent the known numbers, while x represents the unknown, it's the variable. We solve this equation by using the quadratic formula, which says that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. In the quadratic formula, the number under the radical, under the square root sign, b squared minus 4ac, that number is called the discriminant. And so you don't have to write the word discriminant out. There's a shorthand for that. We use the capital letter delta from the Greek alphabet to stand for the discriminant. What the discriminant does, it allows you to determine what type of answers you'll get to this equation. And I'd like to demonstrate this by looking at 3 different examples. First, let's look at x squared plus x minus 2 equals 0. In this equation, a is the coefficient of x squared, so a is 1. B is the coefficient of x, so b is also 1. And c is the constant term, so c is negative 2. Now to find the solutions, we just take and put all 3 of these numbers into the quadratic formula. So the 2 solutions will be x is negative b, or negative 1, plus or minus the square root of b squared minus 4 times a times c. And that's all over 2 times a. Now let's quickly compute the 2 answers. We have negative 1 plus or minus the square root, and the number under the radical is 1 minus negative 8, which is 9. Now the square root of 9 is 3, so the 2 answers are negative 1 plus or minus 3 over 2. If you do this once with a plus sign, you get 1, and if you do it again with a negative sign, you get negative 2. So for this equation, the 2 solutions are 1 and negative 2. Now, the discriminant is the number under the radical. So here, the number under the radical is 9. So the discriminant is 9. What's important in this case is the discriminant is positive, and the 2 solutions to this quadratic equation are real numbers. And in fact, they're different real numbers. Let's see another example. For this example, let's look at the equation x squared minus 2x plus 1 equals 0. We solve this again using the quadratic formula, but first let's write down a, b, and c. A is the coefficient of x squared, so a is 1. B is the coefficient of x, and so that is negative 2. And c is the constant term, which is plus 1. Putting these 3 numbers into the quadratic formula gives us x is equal to the opposite of negative 2 plus or minus the square root of b squared minus 4ac, and that's all over 2 times a, or 2 times 1. So we have x is equal to 2 plus or minus the square root of, if you compute the number under the radical, you get 4 minus 4, which is 0. That's all over 2. Here, you do it once with a plus sign, once with a minus sign to get to 2 answers. In both cases, you get 2 plus 0 over 2, which is 1. Or you get 2 minus 0 over 2, which is also 1. So the 2 solutions to this quadratic formula are 1 and 1. In this case, what you do is you just say the solution is 1 and it's a double root. Another way you could say this is it has multiplicity 2. But these all mean the same thing. So you could say the 2 solutions to this equation are 1 and 1, or it's a double root, or it has a multiplicity 2. These are all different math ways of saying the exact same thing. For this example, the number under the radical is 0, so the discriminant is 0. The takeaway from this example is the discriminant is not positive, it's not negative, it's 0. And when the discriminant is 0, you get a repeated root, 1 and 1 in this case. Let's see a third example. Let's look at the equation 2x squared plus 6x plus 5 equals 0. Here a is 2, b is 6, and c is 5. Let's put these 3 numbers into the quadratic formula to get the 2 solutions. So x is negative 6 plus or minus the square root of 6 squared minus 4 times 2 times 5, all over 2 times 2. So x is equal to negative 6 plus or minus the square root of, and the number under the radical, the discriminant, is 36 minus 40, which is negative 4, all over 4. So this gives us negative 6 plus or minus 2i over 4. So we can divide the top and bottom by 2, and that gives us the two solutions to this equation. X is negative 3 plus or minus I over 2. This is a perfectly reasonable way to write the solution, but if you'd like, you can break it up into the two different complex numbers. You could do it once with a plus sign, and that gives you negative 3 plus I over 2, and then go through and do it again with a minus sign, and you get negative 3 minus I over 2. So these are the two solutions to the quadratic equation, and they're both complex numbers. And in this case, the discriminant is negative 4. The takeaway here is when the discriminant is a negative number, the two solutions to the equation are going to be complex numbers. So to recap, if you have an equation ax squared plus bx plus c equals 0, the solutions are given by the quadratic formula. The number under the radical is called the discriminant and is denoted by capital letter delta from the Greek alphabet. And the word discriminant sounds like discriminate, and that's exactly what this number is used to do. It allows you to discriminate what type of answers you're going to get to this equation. And so let's quickly make a table of what we found. When the discriminant was positive, we got two different real solutions. That's shorthand for saying two different real number solutions. Real numbers include integers, fractions, and decimals. Now when the discriminant is 0, that means we get a repeated real root. And when the discriminant is negative, we get two complex solutions. Okay, so let's quickly recap. The discriminant is b squared minus 4ac. It's simply the number under the radical. In the example x squared plus x minus 2 equals 0, the discriminant was 9, and the two answers we got were 1 and negative 2. But the takeaway here is that whenever the discriminant is positive, you'll get two different solutions, and those solutions will be real numbers. The second example we looked at was x squared minus 2x plus 1 equals 0. Here the discriminant was 0, and what we got was a repeated root, 1 and 1 in this case. And the third final example we saw was 2x squared plus 6x plus 5 equals 0. Here the discriminant was negative 4. It was negative, and the answers we got, the solutions to this equation, were two complex numbers. Before we end the lesson, there's one important thing I'd like to mention. Throughout this lesson, we assumed all the coefficients of the equation were real numbers. So for example, we didn't talk about quadratic equations like x squared plus ix minus 3 equals 0. Here the coefficient of x, I, is a complex number. So everything that we talked about using the discriminant is for working with quadratic equations where the coefficients are not complex numbers. They're real numbers. I just want to throw that out there. We were probably all on the same page. You never thought that we would go to some wackadoodle equation like this, but it's important to be said that if at any point you get off the math freeway and you start working on some very advanced examples or problems, and you start seeing complex numbers popping up as the coefficients in your equation, which does happen in the real world, then you're not going to really use the discriminant. But when you're computing real problems using real numbers, the discriminant is what you want to go to be able to check your answers and know if they make sense. If the discriminant's negative, you know you should get two complex numbers. And if the software you're using or the calculator you're using does not handle complex numbers, you need to be aware of that. If the discriminant is 0, you know you will get a repeated root, and that root should be a real number. And finally, if the discriminant is positive, you should get two different real number solutions.